So whenever I see cosecant, the first thing I like to do is just rewrite it. Who's the sister of cosecant? Sine. So what I'm going to do is rewrite this as sine. And then this is over 1. So when I flip it, it would be 1 over negative 1 over root 2. Yes, because we're trying. If you see it as cosecant, now you may recognize, like I know that this is going to be root 2 over 2. Now, if you recognize that, then you don't have to do this. You can just write it as what it is. So when you rationalize it, you get sine, the inverse sine of negative 2 root 2. What quadrants am I looking in? What quadrant? Tell me with your fingers what quadrant am I looking in? And because it's negative, I'm in which quadrant? I'm in 4. Now you have to be careful with this one though, because this is going to be a reflection. These 3 angles are a reflection of quadrant 1. So this is negative pi over 6. Let me put that down a little bit. This would be negative pi over 4. And then this one here is negative pi over 3. And this would be negative pi over 2. So what would be the answer you would tell me next Friday on the test? Where is sine negative root 2 over 2? Negative pi over 4. So that would be your answer that you should tell me for number 1. I'm going to write the answers in green. All right, where is tangent undefined? Pi over 2. Good. Where is cosine 4? Is cosine ever 4 on our unit circle? That's my first D and E. Okay, who's the sucker? Who's the sister to secant? Cosine. So when you flip this, so you have cosine. And then when you flip it, this is what you would get. And then after you rationalize it, it's a lot of work to rationalize it, but we'll do it. You would get 3 root 3 over 2 times 3, because your root 3s are going to multiply. So what happened here is you would get 3 times root 3 in the top. And then 3 times root 3 times root 3 is 3. But what's going to happen with these 2 3s? They cancel. So you really are just looking for the inverse cosine of positive root 3 over 2. Where is cosine positive root 3 over 2? Pi over 6. I agree. So that would be the answer here. I'm going to write that in green. Hold on. All right. Where is sine negative root 2? It's never, yeah. Cosecant and secant, but not sine. So that's my second D and E. All right, cotangent. Cotangent is cosine over sine. That's the tricky one. That's the cousin, the stepsister. All right, cosine is root 3 over 3. Where is the cotangent? Sorry. First of all, we know we're looking in what two quadrants are we looking in for cotangent? 1 and 2. Anytime it's a positive, we know we're in quadrant 1. So in quadrant 1, where is cotangent going to be root 3 over 3? Pi over 6. All right, let's go ahead and test that. I feel like I don't have any space. So at pi over 6, what is the cosine of pi over 6? Root 3 over 2. And we're going to divide that by the sign, which is 1/2. Is that what you said? Root 3? Wait. Sorry. Angelina, what did you say again? You said pi over 6. All right. So if we try pi over 6, this is pi over 6. Let me go ahead and zoom in right here. At pi over 6, because remember, it would be root 3 over 2 divided by 1/2, which would become, wait, I need more space. Okay. Which would become root 3 over 2 times 2 over 1. So that's going to cancel, and that's just going to leave me with root 3. So it's not that one. So because it's not that one, what's the only other one it could be? There's only 2 options. Pi over 3. Let's check it and make sure. If we do pi over 3, if I take 1/2 and divide it by root 3 over 2, that would be 1/2 times 2 over root 3, which is going to give us 1 over root 3, which after we rationalize it will give us root 3 over 3. So my answer is pi over 6 for this last one. And that would be my 6 answers. Yep, I meant pi over 3. Thank you, Nathan. Appreciate you. So it's either pi over 6 or pi over 3 when you see those root 3s. So you just need to test them out and see which one is going to work. All right, so today we're actually going to start solving equations. So we're starting 7.3, which is trig equations, if you want to go ahead and title your notes. We divided cosine by sine. Cosine divided by sine is cotangent. That's the other one. That would be pi over 6. So pi over 6 is, no, that would be pi over 6. When you divide cosine by sine, you get pi over 6. So for pi over 6, we got root 3. And for pi over 3, we got 1 over root 3, which is going to rationalize down to root 3 over 3. I just didn't show me rationalizing it.
I put the wrong answer for pi over 6.
Oh, sorry. I said pi over 6 first, and then it's pi over 3. All right, so 7.3 trig equations. We already got our notes titled. You can just write trig equations. All right, let's get started. Copy it down. The only thing to remember is the directions, which says find all of the solutions. So this is just a little bit different. So I'll give you about 60 seconds to copy this down, and then we'll start working through them together. So theta is a variable, just like x and y. But in 7.3, it's asking us to solve and find all of our solutions. So solve and find all of our solutions. It shouldn't take a lot of space, so maybe give yourself just a couple of lines. think the key that I want you all to understand for 7.3, or when it's an equation, if it says find all of our solutions, we're no longer limited to just two quadrants. All right, because it says find all of the solutions between 0 and 2 pi. So that means looking across the entire unit circle, 0 to 2 pi. We don't have to flip it to negative. All of our answers should be between 0 and 2 pi. So the opposite of cosine is inverse cosine. So if you take the inverse cosine of both sides, this is going to cancel, and you're left with theta equals the inverse cosine of positive 1/2. So look at your unit circle and tell me there's two places where cosine is positive 1/2. And you're just going to tell me those two places on the unit circle where cosine is positive 1/2. So look at your unit circle and tell me those two places where cosine is positive 1/2. So what would be one? What's in quadrant 1? What would be your answer? All right. And then what other quadrant is cosine positive? 4. So what would be my other answer? 5 pi over 3. And that would be your answer. It's that simple. So again, the opposite of tangent is inverse tangent. So if I take the inverse tangent of both sides, on the left, it's just going to cancel out the tangents, and I'm left with theta, which is x, equals the inverse tangent of positive 1. So on your unit circle, I want you to tell me the two places. There's two angles that have a tangent of positive 1. So we already know one of our answers in quadrant 1. Show me with your fingers what other quadrant has a positive tangent. Quadrant 1 has positive tangent. What other quadrant has a positive tangent? 3. Because in quadrant 3, remember, when you divide two negatives, you get a positive. Tangent is division. In quadrant 3, when you're dividing two numbers that are negative, you get a positive. So I'm looking for an answer in quadrant 1, and I'm looking for an answer in quadrant 3. Go ahead and tell me those two answers, those two angles. All right, so quadrant 1 is pi over 4. And what about quadrant 3? 5 pi over 4. Good job. All right, try to do C by yourself. Do inverse sine and tell me the two angles.
Sorry for the delay. Please send the WIDA students now to their testing rooms. Thank you.
Are they always going to be the same denominator? I have never thought about it like that, ever. I never want to say always. I got to think about that because I've never looked at it like that before, ever. That's a good question, though. All right, -1/2. So sine is negative in quadrants 3 and 4. So what is your angle in quadrant 3 that has a sine of -1/2?
75/6.
And in quadrant 4?
11/5.
Okay. Any questions?
This unit, like the quadrant, is not really, it's just like quadrants 1, 2.
Right. So that's why I want to make sure you have this, like I said at the beginning. Notice what it says at the very beginning. That's different. It says find all the solutions between 0 and 2 pi. So the directions will tell you where to look. Without these directions, I would be limited to my inverse quadrants. But because it's saying find all of the solutions between 0 and 2 pi, that means I'm looking at all 4 quadrants. All right, couple more. Go ahead, copy down D. So tangent is negative in quadrants 2 and 4. So you should be looking for 2 angles, one of them in quadrant 2 and one in quadrant 4. All right, who agrees with my 2 answers? 5 pi over 6 and 11 pi over 6. So tangent is sine divided by cosine. I really like the way Mr. Suchi explains it, where he talks about the slope. If it's √3 over 3, you know you're looking for a slope less than 1. So if we think about that this is 1, so I needed the angle less than 1. And the same thing here. This, we're having green, these have a slope of 1. So we wanted an angle closer to the x-axis. Now, if that confuses you, you can always rely on what you know, which is sine divided by cosine, and figure out which one, because there's only 2 options that you have. All right, go ahead and do E. If you haven't already, do E and F. And then we'll compare our answers. So everyone should be trying to work through E and F. Okay, I don't see anybody working anymore, so go ahead and check your answers. For E, I had pi over 4 and 3 pi over 4. Who had that? All right, good. And for F, I had pi over 2 and 3 pi over 2. Who had that? All right, any questions? What I noticed, though, is on the test, the only, like, if you didn't do well, it was mainly because your unit circle was filled in wrong. So just next Friday, you're going to get another blank unit circle. You got 2 more tests where you get a blank unit circle, and then we're done with it. You have to know the unit circle. You have to. It's the foundation of trig. All right, couple more questions, and I will show you your tests. So these are a little different because they have exponents. So I'm just going to give you a chance to copy down A, and then we will talk about it, and then we'll do B together because I'm not sure how much space. So we have sine squared of theta equals 1 over 4. That's the difference, is we're adding in an exponent. We're going to talk about how do we take care of an exponent. So just copy down A, and then I'll give you, we'll work through it together, and then we can do B and C. You'll see that it's really not that bad. You probably can figure it out, but how do you get rid of a square? There's only one way to get rid of a square. How do we do that? Square root, yeah. So that's what we're going to do. We're just going to take the square root. Yes, you can take the square root of sine. You sure can. And when you square root a fraction, all right, so when we take the square root, we have just the sine of theta. And that equals, and this is the key that you have to remember, whenever you take the square root, it's positive and negative answers. So when you square root a fraction, what is the square root of 1? So you square root top and bottom when you square root a fraction. So what's the square root of 1? 1. What's the square root of 4? 2. So there's actually 4 answers. Well, we're not finished yet. So we have the sine of theta equals plus and minus 1/2. And then we would do the opposite of sine, which is inverse sine. And that would cancel that out. So what I'm really looking for on my unit circle is where is theta, what angles have an inverse sine of positive and negative 1/2. So there are 4 answers that I'm looking for. So on the unit circle, tell me all the places where sine is positive or negative 1/2. So sine is positive and negative 1/2. So that would be pi over 6. I'm just going to start in quadrant 1. So every single quadrant we have an answer. So in quadrant 1, it would be pi over 6. In quadrant 2, it would be what? Yep. In quadrant 3, it would be 7 pi over 6. And in quadrant 4, 11 pi over 6. That's it. That's all it's to it. It's pretty simple, right? You might be right. You know, I never thought about that. I never thought about that, Marissa. I have never made that connection that the denominators are all the same. Okay, let's look at question B. So we're going to take our square root. And this should go pretty fast. When we take our square root, we have the cosine of theta equals plus or minus root 3 over 2. So how did we get to root 3 over 2? We got to root 3 over 2. Here, let me go ahead and slow down a little bit. When you take the square root of 3, that stays the square root of 3, right? Because that's not a perfect square. But 4 is. And the square root of 4 is 2. So on your unit circle, you're going to tell me all of the places that have an inverse cosine or cosine of root 3 over 2. Which just happens to be the same answers that we get in part A. That's just a coincidence, though. All right, let's talk about tangent. So we're going to take our square root first. It's our last question. And we have that tangent of theta is plus and minus the square root of 3. So on our unit circle, we are trying to find all of the angles where tangent is positive or negative root 3. So if we think about it the way Mr. Suchi explains it, which is about slope. If your slope is square root of 3, square root of 3 is more than square root of 1. So this is my square roots of 1s. Let me go ahead and trace those in green. In every quadrant, we have a slope of 1. And that's what I just traced in green. We want all of the angles that are bigger or further away from the x-axis, which would be this angle, and this angle, and this angle, and this angle. If you think about it in terms of slope. Because this is a steeper line than what I have in green. This is steeper. My slope is greater. So my answers would be pi over 3, two pi over 3, 4 pi over 3, and 5 pi over 3, sorry. All right, even though this is the last question, I just need for you all to copy down the next question so we're ready for tomorrow, because we're just a little bit behind our schedule, just a tiny bit. So take a minute and copy this question down, and then we will